Static configuration is attached to the software at startup, either by environment variables, command line arguments, or a config file. Something that trips people up when they start out is that only one of these can be used. The configuration file has the highest priority, followed by command line arguments, and finally by environment variables. Choose which one you're going to use and stick to it. Traffic Proxy on K3s uses command line arguments, which you can see if you look at the deployment or the pod manifest. The static configuration tells Traffic Proxy what entry points to use and which providers to enable. An entry point is a port where Traffic Proxy listens. A provider is a backend provider like Kubernetes that Traffic will pull for updates to the configuration. There are loads of providers, and they aren't all enabled by default. In the case of K3s, only two providers are in use: Kubernetes Ingress and Kubernetes CRD, which is the custom resource definition provided by Traffic Labs, and which we'll also review a little later on in this class. For now, just know that enabling a provider tells Traffic Proxy to pull that provider for information and to use that information to assemble and maintain its dynamic configuration. Usually, you'll only activate the providers that correspond to the environment in which Traffic Proxy is running. An entry point is the port where traffic enters Traffic Proxy. That's it. It's a port. But what's special about it is that it is protocol independent. Have you ever wanted to serve HTTPS on port 443 for one site and also pass it through as straight TCP for another site? You can't do that with any other ingress controller. You have to terminate TCP on a different IP address, or else you have to terminate TLS and then forward it as TCP, forfeiting all of the layer 7 stuff that you might want to do for an HTTP transaction. We tend to associate ports with protocols because if you have a web server listening on port 80 or 443, you know that it speaks HTTP or HTTPS, and that's it, right? This isn't true with Traffic Proxy. The port is just the port. You could configure Traffic Proxy to receive TCP and HTTPS requests on port 443, have it process TLS and HTTP headers for one, and pass TCP traffic for the other to some backend that has its own TLS certificate. You can do whatever you want with it. And starting with Traffic Proxy 2.5, you can even handle HTTP 3 requests. Traffic Proxy can do other things that we won't get into in this class, but I want you to be aware of them. It comes with support for dynamic tracing with Jaeger, Zipkin, Datadog, Instana, Haystack, and Elastic. It will also expose metrics for use with Prometheus, Datadog, InfluxDB, and StatsD. Finally, you can write logs to a file or standard out. Log shipping is off by default, but if you turn it on, you can get logs in common log format or in JSON. The options to activate and configure each of these are also part of the static configuration.